Hi everybody. The goal of this video is to describe what average rate of change is and instantaneous rate of change is. I'll also cover units and what the connection is between secant line and tangent line. So to start out with, we're going to use the data from the share of the population living in extreme poverty. We're going to just use the countries that populate automatically. And I'm going to go ahead and actually only look at Bangladesh because it is the most interesting to look at from a functions perspective. So I'm just going to go ahead and remove all the rest. And now suppose I'm interested in the question, how did the share of the population living in extreme poverty change from 1983 to 2016? To find that out, what I'm going to do is find the average rate of change, which is the rate of change between 2 points. If I put this a little bit differently, I could draw a line that connects my first point to my second point, and then I could find the slope of that line. That line that connects those 2 points is called the secant line. So to find the average rate of change from 1983 to 2016, I'm going to find the slope of the line that connects those 2 points. And if I do that, then what I have is 14.8% minus 29.9% divided by 2016 minus 1983. What I get is negative 0.46. But what are the units? The units are the units of y divided by the units of x. So my units are percent, which is the units for y, divided by year, which is the units for x. So my average rate of change from 1983 to 2016 is negative 0.46% per year. So on average, it decreased 0.46% per year. It doesn't matter what happens between 1983 and 2016 for an average rate of change. You just care about the starting point and the end point. Now suppose I wanted to know, how was the share of the population living in extreme poverty changing in 1986? In this example, I'm looking for an instantaneous rate of change, which is a rate of change at a point. What does that mean? Basically means, what is the slope of a line that linearly approximates the curve at a point? Put another way, a tangent line. This will make more sense when we look at equations and graphs. Looking at data is a little bit tricky here. We can't find the instantaneous rate of change in 1986 because we only have data from 1985 and 1988. So with data, in order to find an instantaneous rate of change, I have to estimate using the 2 closest points that I can. So an estimate for the instantaneous rate of change uses the slope of the line between the point at 1985 and 1988. So I have 37.8% minus 25.4% divided by 1988 minus 1985. So I get 4.13. Again, the units are the units of y over the units of x. So an estimate for the instantaneous rate of change in 1986 is 4.13% per year. And I'm going to put here, this is an estimate, and it's an estimate because we have real data. Okay. So we have the average rate of change is the rate of change between 2 points. And instantaneous rate of change is, how is the function changing at that exact point? We will, in a week or two, calculate instantaneous rates of change using a mathematical concept called limits. For right now, we're just trying to develop the big ideas. So now we're going to take a look at one of the functions that we've been working with, f of x. Okay, so let's go ahead and graph f of x. Here's my graph of f of x. Now, if I'm interested in an average rate of change, I'm looking at how has the function changed between 2 points. So an average rate of change could be looking at 2 points, let's say -5, and what should we go to? Should we go to +5? Do we have enough parentheses now? There we go. So if I want to label each one of these, I have my 2 points. And the line that connects them is called the secant line. And the slope of this secant line, you can visually see, is 0 because the change in y is 0. If I had units in x and y, then the units would be the units of y over the units of x. So my average rate of change between x equals -5 and x equals 5 is 0. If I wanted to change that, and I wanted to look at what happens between x equals 0 and x equals 5, I could find that secant line that connects those 2 points, and I could find the slope of this line. Now, it's a lot more interesting to talk about instantaneous rate of change. So an instantaneous rate of change is how the function is changing at a point. And we're going to go back to the point that we looked at in a previous video. And the instantaneous rate of change is the slope of the line that we get when we zoom in until our function looks locally linear at the point that we're interested in. I've already shared with you that you could calculate this using Desmos. And we get 0.97 is the slope of this tangent line. Again, we're going to learn how to calculate this more formally in a week or two. For right now, what I want you to think about is this is the slope of the line that you get when you zoom in at a point. So it's the tangent line. So I'm going to go ahead and just put the tangent line down. Okay, and this is our tangent line. Notice that it is a line that goes through a point that we specify. Now, our tangent line might hit the function at other points, but that doesn't matter. What matters is the point on the line, on the tangent line, is the point of our function that we're interested in, and the slope of the tangent line is the same as the slope of the line that we get when we zoom in. So, average rate of change has units of whatever the units of y are over the units of x. And the average rate of change is found by finding the slope of the line between 2 points. And that line is called the secant line. The instantaneous rate of change also has units of what the units of y are over the units of x, but instead looks at the slope of the line that you get when you zoom in, or the local linear approximation. That's also called the tangent line.